Hello, this is Mrs. Raro, and in this video, you will learn how to identify trigonometric ratios. All right, and these are only used with right triangles. Okay, let's begin. All right, so in a right triangle, we have three sides that you must identify, okay? The three sides are called opposite of an angle, adjacent to the angle, and hypotenuse, which is always across from the 90-degree angle. So if you identify where the 90-degree angle is, then across from it, right, or opposite of it, is your hypotenuse. Okay. Now, opposite side and adjacent side can interchange depending on what the angle is. So this is the 90-degree angle. This could be any angle. They're naming it angle A, let's say, for example. And I can name this angle B, for example. All right. So based on angle A, then this side right here is its opposite side. All right, so I'm going to highlight it yellow. So based on angle A, then the yellow side is its opposite side. Okay, and then based on angle A, the adjacent side is this side, which is green. Okay, now I'm going to erase that. Now based on angle B, the opposite side, and going to highlight it yellow, is now this side. Okay, and the adjacent side to angle B is now this side. Right, so you have to learn the three names: opposite, adjacent, and hypotenuse. The hypotenuse never changes because it's always across from the 90-degree angle. Okay? All right, so let's begin. We begin trigonometry by identifying the three trigonometric ratios. Using these trigonometric ratios, it means that we are comparing two sides based on the angle. Okay? Two sides of the triangle based on the angle. So the definition of sine of an angle is comparing the opposite side, the numerator, divided by the hypotenuse, or over the hypotenuse. Cosine is defined or identified as the adjacent side over the hypotenuse, and tangent is identified as opposite side over the adjacent side. So this is called sine, this is called cosine, and this is called tangent. Now there's a better way to memorize this, and we call that SOHCAHTOA. You might have heard that expression, SOHCAHTOA. All right. S in SO stands for sine. O stands for opposite. And H stands for hypotenuse. Okay. Ka means cosine. And then A stands for adjacent. And then H stands for hypotenuse. And then TOA stands for tangent, is its opposite over its adjacent. All right, so now this is going to be a great tool for you to remember when we're doing trigonometric ratios. SOHCAHTOA. Okay? All right, so let's start out with these two triangles. Let's do this triangle first, triangle ABC. Okay? Now we've identified that this is the right angle. I have identified that this side length is 3, this side length is 4, and then the hypotenuse here is 5. If I were you, I will always need to identify where the hypotenuse is because that will never change. Okay, then this is angle A, and then this is angle B. All right, so let's begin. Let's say we wanted to calculate the sine of A, angle A. All right, so sine is SOH, S-O-H, which is identified as the opposite side over the hypotenuse. All right, so the opposite side here is letter A. The right across from it is its opposite side, so I'm going to highlight that one yellow. Okay, so the opposite side here is 4, so we place the number 4 in the numerator. over the hypotenuse, which we've already identified, which is 5. So the ratio of its opposite side to the hypotenuse is 4 to 5. So this is your final answer. And you can also reduce that if it's reducible, right? But you could leave it as a fraction. Okay, so let's talk about cosine now. So I'm going to erase this. Actually, I don't have to. All right, so cosine of A. Okay, so cosine is ka, which is identified as adjacent side over the hypotenuse. So the adjacent side, I'm going to highlight it in green. This is letter A. If this is the hypotenuse and this is the opposite side of A, then this has to be the adjacent side. It's the one next to A, but not the hypotenuse. All right, so in this case, 3 will be the adjacent side. So I'm going to place the number 3 at the numerator, and then the hypotenuse is 5. So 3 over 5 is the ratio of cosine of angle A. Okay, and now we move on to tangent. So tangent of A is TOA, so which is opposite over adjacent. All right, so the opposite side of A is 4 and the adjacent side is 3. So these are your 3 ratios: cosine of A, sine of A, cosine of A, and tangent of A. Okay? All right. Now I'm going to clear this and I'm going to work with B. Sine of B, which is again identified as so, which is opposite over hypotenuse. Here is B. The opposite side is right here now, so it's 3. Okay, so notice how it's different. So 3 over, and then the hypotenuse is 5. So that's your sine of B. Okay, where sine of A was 4 over 5, sine of B is 3 over 5. Okay, now cosine of B, all right, which is identified as adjacent over hypotenuse, so ka. All right, and then the adjacent side is 4. This is the adjacent side next to B, so that is 4 over the hypotenuse, which is 5. So that's the ratio, 4 to 5 ratio of cosine. Now tangent of B is TOA, which is opposite over adjacent. Okay, so opposite side of B is 3 and the adjacent side is 4. So the ratio there is 3 to 4. All right, and that's it. All right. Okay, so let's take a look at some more problems. It says in the triangle of RST, the measure of 90 degrees is on angle T, and then SR is 65, TS is 33, and RT is 56. So what is the value of sine of R to the nearest hundredth? So they want you to actually divide that, okay? All right, so first we make a right triangle because it doesn't show. To the best of your ability, mark where the right angle is. The right angle is T, and then this must be S, and then this must be R. It doesn't really matter. That's R or that's S, okay? And now we're going to label what we know. SR is 65. And then TS is 33. TS is 33. And then RT is 56. Okay, so now we're going to find the value of sine R. So sine of R is so, and that means that we're comparing the opposite over the hypotenuse. So we already know that this is your hypotenuse because it's across from the 90-degree angle. Now we have to find the angle R, which I'm going to mark as yellow, which is right here. So the opposite side of R is right here, which is 33. So now we want the numerator to be 33. And we want the denominator to be the hypotenuse, which is 65. So this is our ratio. All right, so we can, it's asking to the nearest hundredth, which means to divide 33 divided by 65. Okay, so that's 50.769. So This is equal to 0.507, right? So which rounds up to 0.51. So this is your final answer. That's the ratio, 33 over 65. Okay? All right. It says here in triangle KLM, the measure of M is 90 degrees, KM is 48, LK is 73, and ML is 55. What ratio represents cosine of L? So this one doesn't ask to round it off to the nearest hundred, so we could just leave it as a fraction that's reduced. So we're going to draw a triangle, right triangle. Identify where the right angle is, which is angle M. And then write K and then L. Okay, and again, it doesn't matter. You can interchange these as long as you're not interchanging the right angle. KM is marked as 48. LK is 73. And then ML is 55. All right, identify where the hypotenuse is so you don't get confused between hypotenuse and adjacent. So cosine is Ka. And we want to find the cosine of L. So Ka means adjacent. We're comparing the adjacent side over the hypotenuse. All right, so I'm going to mark the adjacent side green. And so the adjacent side. So here's L. The one that's close to it is this, 55. So that's the adjacent side, okay? So the numerator is 55 and the denominator is 73. And that's exactly what you would enter. Okay? All right, here we go. This is our last one. In triangle OPQ, the measure of Q is 90 degrees, PO is 17, QP is 8, and OQ is 15. So what's the ratio that represents tangent of P? So again, we're going to, oops, sorry about that, create a right triangle, identify where the right angle is, and label it Q, because that's what it says. You can put P here and O here, or vice versa. So PO is 17. QP is 8, and then OQ is 15. All right, we want tangent of P. So TOA is representing tangent, and the two sides that we're comparing is opposite over adjacent. So again, the opposite side of P, so here's where P, yellow. The opposite side of P will be the one across from it, which is right here, okay? And then the adjacent side of P is right here. It's the one next to it because 17 is the hypotenuse. So the opposite side is 15 and the adjacent side is 8. So this would be your final answer. All right. Thank you for watching, guys. Bye.